To find the domain of a combination of two functions, we'll first need to consider the domains of the individual functions themselves. Let's recall that f plus g is shorthand for the f plus g of x function, which is shorthand for let's take the f of x function and add the g of x function to it. The domain is the set of allowable inputs, or the values that we're allowed to plug in for x. So if an element is in the domain of the f plus g function, that means it has to be an allowable input for both f and for g. Similarly, f minus g is shorthand for f minus g of x, which is itself shorthand for take the f function and subtract the g function from it. And so again, if we have an element that's an allowable input for the f minus g function, that element has to be an allowable input for f and for g. So to find the domains of these functions, the first thing that we want to do is to figure out what is the domain of f and what is the domain of g, and then we want to find where those two domains intersect. Let's say the same thing, but this time using a concept drawing. Let's say that f had some restricted domain here, and g had some other restricted domain. So we would have found f and g's domain. Then we would find the intersection, or where these two domains overlap. So the elements that would work in the f plus g and f minus g functions would be the elements that work in both domains, or the intersection of these two domains. So we can describe the domains of f plus g and f minus g using some more math symbols by saying that it's where the domain of f and the domain of g intersect. This is a symbol for intersection. It's also a symbol that means the word and. It means that the elements need to be both in the domain of f and in the domain of g, or where those two domains intersect. Now let's look at the domains of f times g and f divided by g. Similarly, let's recall that f times g is shorthand for f times g of x, which is itself shorthand for f of x times g of x. And so again, if an element is going to be an allowable input for the f times g function, it has to be an allowable input for both the f function and the g function. And so again, we'll say here that the domain of f times g has to be where the domain of f intersects with the domain of g, or where those two domains overlap. Now with the f divided by g function, there's one additional thing that we need to consider. Recall that the f divided by g function is shorthand for f divided by g of x, which is shorthand for f of x divided by g of x. And so again, the element that gets plugged into the f divided by g function does need to be an allowable input for both f and for g. And so the domain of the f divided by g function does begin with the intersection of the domain of f with the domain of g, or where those two domains overlap. But with the f divided by g function in particular, we would additionally exclude any x value that would cause this g of x function to be equal to 0. The output of g cannot be 0 because it occurs in the denominator of the fraction. So we're going to exclude any x that would cause the g of x function to be equal to 0. So to find the domain of f divided by g, we're going to begin with the intersection. Again, it has to work in f and in g, but then we're going to additionally exclude any x value that causes the g function to be 0. So when we write these domains in interval notation, that element would be left out.